Welcome back from spring break, everybody. Hope you had a restful, relaxing, fun vacation. It was sure beautiful. We had some great weather. So now we're back at it. We've got 4 weeks until your AP exam, 4 weeks from today, in fact, Tuesday. And so let's get to it. Unit 5 of our Calc Medic. We're going to finish these units up of review this week. And we're working towards staging our mock AP exam on the 16th of April. So what I want to start here is looking at the different functions. We've got an F function, an F inverse function, and an F prime function and an F double prime function. And an AP question is most often going to start here. All right, it's going to give you a derivative, and it's going to ask you to answer questions interpreting that, both what I consider backwards, which is meaning looking back at the original function, but also going forwards, looking towards the second derivative function. But most often you'll be given an F prime function. All right, so that go down on your notes. That's going to be your first AP exam tip for this unit, is that FRQs generally involve an F prime. Okay, so an F prime graph. And you as a student are asked to reason both forwards and backwards. And then you got to justify your reasoning. You got to have good, solid evidence to back up why you're claiming what you're claiming. So let's go back up and let's talk about how we create some of that evidence. Okay, we kind of talked about that in Unit 4, but we'll talk about it again as it relates to a graph here in Unit 5. All right, so let me just clean this up a minute. So I've got some space to work. Okay. So let's start with the statement that F is increasing, which you would base on that F prime graph. Okay, now F prime, when F prime values are greater than 0, so that's when we've got all of these positive values here for F prime, and that's how we're going to justify that F of x is increasing. You can't do anything with the second derivative from that, but you can tell that f is increasing. F is decreasing. The justification would come when that first derivative is less than 0. And so we have all these values, negative values here. And so that would be when f is decreasing. So having a relative maximum, now that is the key part of where that change happens. And so we've got a change happening twice here, where negative values turn to positive and positive values turn to negative. And so we're going to have that maximum is going to be at b, which is going to correspond to the b value of the f of x. So we say f of x has a maximum at b because at b as well, the derivative is changing from positive to negative values. And so that first derivative would be that f prime of b equals 0 and, okay, it has to be both, and is changing. Okay, and we know the way that it's changing is from plus to minus. And then having that relative minimum will be happening at a. And so my value here at a gives me a relative minimum for f of x. And so it has a minimum because f prime of a is 0 and changing from minus to plus. Okay, however, we can also look at the second derivative and have reasoning from that as well. Because what's happening at these values, where the a and the b are. So if you kind of figure out where a and b are on your graph of their second derivative, a is about right here, and b is about right here. And so we also can say that it is a relative maximum. Because f prime at b equals 0, we could also use the reason, and f double prime at b is negative. So how can we claim that? Because if f prime is negative, okay, having that negative value down there, this is where that would be sitting. I'm gonna make that just a slash mark, not a, there we go. Okay, because we've got concave down. Negative second derivative means it's concave down, which means the shape of that is curving in such a way so that you're going to have that negative concavity, creating a maximum sitting on top of it. And then in a similar way, you could say, well, f prime of a was equal to 0, but also f double prime of a is greater than 0. So sure enough, f double prime at a is greater, which means it's concave up, and that's giving us a minimum. So you could use either of those reasonings to justify. Notice that both of them start with being equal to 0, but then there's also a second part. We could also have, where we've got these equal to 0, we could also have other situations where we would have undefined. And so if f prime is undefined, then that's a place where the derivative graph is broken. Maybe an asymptote, or a gap or jump discontinuity, some kind of discontinuity. Okay, f of x being concave down. How can we tell that from the first derivative? Well, looking at the first derivative, if that's what we're given, this whole section would represent the original graph being concave down, because the slope of the first derivative, which is the second prime, would be negative. So f being concave down means that we could say that the slope of f prime of x is negative. And then if we want f to be concave up, that would be the whole section here. And that would be where the slope of f prime is positive, which is also the result of a change, a point of inflection. And so we'll have a point of inflection where the slope of f prime of x changes. And we'll call that point C here, which is going to line up with point C in the second derivative. So how could you say that I use the second derivative to justify that f of x is concave down? Rather than saying the slope of f double prime is negative, you would say the values of f double prime are negative, or the values of f double prime are positive. Or you could say the values of f double prime are changing. So a goodly part of the FRQs are going to be your justification based on looking at a graph. Okay, Unit 4 was looking at the algebra of it and solving, making maybe a first or second derivative chart. This is looking at a graph picture and making the conclusions that way. All right, so that comes down to our second AP exam tip. So tip number 2, that behavior for f of x must be justified by referring to behavior of the other two. So of the first derivative or the second derivative. Okay, so your explanations, they should be concise, they should be to the point, don't make it wordy. That more words is not going to impress them. Say it succinctly. Okay, make sure you cover everything you need to say, but do it in a brief way. All right, you don't have time to be all flowery and fancy. Just get to the point and make your case. So here's an example of an FRQ type problem. So here we are given the graph of H prime. So make sure you know what you are looking at. So we've got minus values all here, and then a bunch of positive values, and then more positive values again. So only one change from negative values to positive values. We also have positive slope and then changing but staying positive slope, and then negative slope, and then changing back to positive slope again. So that did change twice. All right, so the question, on which open intervals is h of x decreasing? So a decreasing h of x corresponds to negative values for the first derivative. So a concise, changes at -3. So we would say h of x is decreasing. Now say where it's decreasing. So on the open interval, x less than -3, because, and now in a concise way, reference what the derivative is doing, because h prime of x is less than 0 on that same interval, period. Okay, it's not fancy, it's concise, it covers everything we need to do. All right, so then where does h of x have a relative minimum? So h of x has a relative minimum where, well, it only changed one time. It changed at -3. So you say where, because. All right, now we have to have two parts of the reason. Okay, it has a relative minimum because h prime of 3 equals 0, and h prime of x values change from negative to positive. Okay, good, clear, concise. I've covered everything I need to do. All right, where does h have a point of inflection? All right, well, it has 2 points of inflection, where we changed from yellow to green and then back to yellow again. So it's going to have a point of inflection at 0 and at 3. All right, so we stated where, because, and now we state why. The slope of h prime of x changes nature. Okay, at those places. Or you could say the values of h double prime. Okay, that would be another way. The values of h double prime change nature here. So that's equally substituted. All right, so your focus today is going to be on reading and interpreting graphs, both forward and backward. Your multiple choice will be just asking you to identify different intervals and making interpretations that way. Your FRQ will have more of a focus on the justification of it, okay? Also, make sure every night you're going through those flashcards that you've made. All right, you're doing your 10 multiple choice, you're doing your FRQ, and then zip through those flashcards, okay? Just to keep those theorems and definitions fresh. That's going to most often help you on multiple choice questions, knowing those theorems and knowing those definitions, okay? So I look forward to getting back together with you tomorrow in class, all right? Have a good Tuesday. See you Wednesday.